Let's walk through all of our exponent rules and talk about how these apply, and I'll prove it out with some real numbers as well. So this first equation is equivalent to like 5 to the third times 5 squared is equal to 5 to the fifth. And this is probably more easily shown if we did it with 2 cubed times 2 squared, which would equal 2 to the fifth based on this rule. And 2 cubed is worth 8, 2 squared is worth 4, and 2 cubed is worth 32. And if you look at this, this is actually factual. 8 times 4 is 32. And that is just one example of a proof of this formula in action and why it works out the way it does. So if you have multiplication between common bases with exponents, you keep the common base and add the exponents together. And that's our rule for multiplication between common bases. Now, just like multiplication and division are brother and sister, and addition and subtraction are brother and sister, we can use that information in how we think about division here. So in division with common bases, we end up with the difference of those two exponents as our exponent on the solution. So if we had 5 to the fifth divided by 5 squared, that would equal 5 to the third. Now, in this example here, it's slightly different. So we've done multiplication, we've done division. Now we're doing exponent, a base to an exponent to an exponent. And so if we had 2 to the third squared, that would equal 2 to the sixth. And 2 to the sixth is equal to 64. And that should be equal to 2 cubed, which is 8 squared. And as we know, 8 squared is 64, and that's an example of this rule being played out with real hard numbers and proving that it works. This equation here isn't much of an equation, but it just says if we have something like x to the negative 2, that's the same as having 1 over x squared. So the negative symbol doesn't make the answer negative. It just means that you have the inverse of whatever your formula or whatever your variable would look like without that negative sign in front. So you get the inverse and you drop the negative sign. And the inverse just means 1 over. All right, so xy to the a, this is a situation where we have something like 10 squared. And this means we're going to get 10 squared equals 5 squared times 2 squared. Because two numbers multiplied together to a base, so like 5 times 2, is equal to each of those numbers separately taken to the exponent and multiplied together in the middle. And we know this is true because 10 squared is 100, 5 squared is 25, and 2 squared is 4. And as anyone who's ever added 4 quarters to get a dollar knows, 25 times 4 equals 100. So this is probably the most important rule. I would put a star next to this. Most people forget this rule. And it's really useful in helping to divide numbers like 1,000 by 125, because this is 10 cubed over 5 cubed, which means we must get 2 cubed out. So final situation to think about is distribution. If I have something like 5 to the fifth plus 5 to the fourth, the only thing we can do here mathematically is to distribute. You're always going to want to take out the lesser of the two exponents. Even if they're negative numbers, you're going to want to take out the more negative of the two. And here we're going to take out the 4, so we're going to take out 5 to the 4. Now what would we multiply to get 5 to the fifth? We'd multiply by 5 to the 1 because you add the exponents there. And then what would we multiply to get 5 to the fourth? We would multiply 5 to the fourth times 1. So this is what we get, and on the interior here, 5 to the 1 plus 1 gives us 6. So we end up with 5 to the 4 times 6 as the solution to this situation. They can make this more difficult by doing things like 5 to the x minus 2 plus 5 to the x. And I would actually want to pull out the 5 to the x minus 2 here. And what that would give us is 1 plus 5 to the 2 on the interior, which if you solve this is 5 squared is 25, so this gives us 26 times 5 to the x minus 2. And what we notice is on the interior of these parentheses, we always get a number that looks different than the original numbers we were looking at. Like in both situations, we only had 5s, but here we get 2 times 3, and here we get 2 times 13. So we get different factors out of the addition process that takes place in parentheses, and that's probably the biggest takeaway and the one thing to remember when you're dealing with distribution.